Okay. I also record our lectures so that if you're absent, okay, if I remember to record them, because sometimes I don't. If you're absent, you can go on to Google Classroom and find the lecture so that when you come back, you can catch up, okay? It's not I'm trying to get you in trouble if you're talking. It's this way. This is a tool for you to use when you're absent, or if you don't remember what I said, you can go on to the YouTube channel and look at the material. Does that make sense? Okay. All right, so let's get started. Every time I'm always going to title it with the date, so 8/27/24, and, oops, you cannot see that. And I will title it with the lesson name, okay? This way I can tell you, hey, go back to when I talked about limit. Go back to when I talked about product rule, and you can hopefully quickly go through your notes and figure out what day that was, okay? Always title your notes. So today we're going to be talking about limits and the definitions and their definitions. Again, if I go too fast, please, 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 please stop me. Do you need paper? Okay, I'm going to start with the definition of a limit. So this is our first introduction to calculus. The limit is the value, which means that this is going to be a number or variable. Please let me know when I'm off screen. And can everybody see that? Do I need to zoom in? Okay. Of a function or graph as the x value gets closer to or we call this approaches, and I'll talk about that in a minute, some number. I'll talk about what all this means when we get to the examples, but you need this definition in order to understand the rest of the stuff. So the limit of a function is the value. So we're going to look for a number or variable. We'll get to variables a long time off. Of a function or graph as the x value gets closer to or approaches some number. All things in math, we don't like to write a lot. We don't like to write tons of words, so we have notation. So the notation for this is as follows. And then I'll write how we read it and what part goes to what. Can you see that color? Can anybody not see that color? Okay. It's going to be the limit as x approaches a of f of x is equal to b. And I'll specifically write how you say it in words. Because we don't say lim x arrow a f parentheses x parentheses equals b. We don't say that. I don't know. Okay. Can I move down right there? Right there? Okay. All right, so we read this as follows. It's read the limit And then I'll write underneath the symbol of f of x So see, limit is the symbol lim, f of x, as x approaches the x approaches a. So x arrow a is x approaches a, is equal to b, or not to b. No laughs. Okay, so when you see these symbols, you should be reading it like this. The limit as x approaches a of f of x. I'm sorry, the limit of f of x as x approaches a is equal to b. Or you can read it this, the limit as x approaches a of f of x. Sorry, you can read it both ways. Questions? Am I going too fast? Too slow? Just right? Kind of. Fast or slow? Okay. Can I move down right there? Does everybody have the top part? Okay. As a note, A and B can be the following. A and B can be numbers. Positive, negative, fractions, decimals, square roots, cubed roots, fourth roots. It could also, we'll talk about this later, go to negative or positive infinity. It can also go to negative or positive infinity. So we'll talk about this one later, but right now we're going to do numbers, but we need this for later. Or it can also not exist. And we call this does not exist, DNE. Okay, today we're going to talk about, so today is 8/27, we're going to talk about this and this today, okay? We'll get into negative and positive infinity another day. We've got a couple more definitions and notes, and then we'll get to the examples, okay? A couple more definitions and notes, and we'll get to the examples. Can I get a thumbs up for those of you who are done so I can gauge if I can move on? Okay. A couple more people. And if you ever miss the notes because you're in the bathroom or get pulled out, because I write them down, you can come grab them if I'm done with them and then catch up. Okay? Do you need me to zoom in? Anybody need me? What's what? This?
The second asterisk.
Yeah. This one is negative, positive, infinity. Negative, positive, infinity. I write my infinity like that. You can write your infinity like the sideways 8. We get it out at 10:06, 10:04. 04. Last year was 06. Okay. Ready? Okay. Okay. A couple more definitions and then we'll get to the examples. If anybody needs that paper, let us know and we'll give it to you. Point of discontinuity. Discontinuity. Okay. You're going to see that I do spell some things wrong sometimes. I'm, not perfect. I also do make mistakes, so please catch me sometimes. Okay. The point of discontinuity is a point on a graph, point or points, on a graph or function where the function is undefined. This could mean that there is a hole there or a jump. That's a hole or jump. At least for sake of limits. This is we're talking about sake of limits. Okay? I'll explain what that looks like when we get to the examples. Okay? One of the most important concepts of limits in calculus is that two sides of the graph must get to the same point, and you'll see what I mean in a minute, okay? So, highlight this, star this, do whatever you need to do to make sure that you understand that this is super important. For a limit to exist, so for there to have a value, both parts of a graph or table or function, left and right side of a graph must reach, am I off screen? Okay, the same, oops, I spelled the same wrong. Number, even if there is, am I off screen yet? Oh, thank you. Hole or jump. And again, I'll explain what all that means when we do our examples. Do we like it lighter or darker? Lighter? That good? Ooh, too light. Is that too light? Okay. That good? Okay. All right. When you're done writing this down, you can leave this out, your notes out, but also take out the sheet that Mr. Esquivel passed out. Again, you can leave this out, but also take out that sheet that Mr. Esquivel passed out. Does anybody need this to catch up? Either of these? Catch up with notes? Nobody? You good? Can I get a hand if you are still writing? Okay, thank you. Are we good now? Those of you who are still writing? Ready? Okay, can I go? You sure? All right, nobody's saying anything. All right, so let's look at our first example. We can find limits from graphs, we can find limits from tables, we can find limits from actual equations. Directions say estimate the limit of the function, so we're looking for the y value or the f of x value. Okay, we're looking for the y value or the f of x value. And then write limit notation. So the first thing you want to do is you need to find out what x value it's approaching. So we need to look and see what x value your graph is getting, or sorry, not graph, your table is getting closer and closer and closer to. So let's look here. Our table is getting closer and closer to what number? 1. Are there any questions on how we got that? You sure? Okay, I see some confused faces. So we have 0.75, right? 0.9, 0.99, 0.999. The next, it's getting closer and closer to 1 because if we round this, it ends up being 1. Does that make sense now? If we round it, it ends up being 1. Because when I round this to the whole number, this ends up being 1, right? Okay. The next thing you want to do is you want to find your your y value. And this is the estimate of your function, okay? So if I look at this, as x increases, okay, we can go increases or decreases, but right now we're going to go, increases. What is the value getting closer and closer to? What is it going to round to? 3. Okay? This is my y value. Make sense? No? Okay, so let's look. This is 2.3, right? This is 2 if I round. This is 3 if I round. This is 3 if I round. This is 3 if I round. So your function is getting closer and closer to 3. Does that make sense now? For those of you who are confused? Okay. The next thing you need to do is to write it in limit notation. Okay? So remember, limit notation looks like this. The limit as x approaches a, this is your x value of f of x, is equal to b. This is your x, and this is your y. This is your x, and this is your y. So we're going to start. The limit as x approaches, what number did we find for x? What number did we find for x? 1. Am I going too fast? Anybody? Okay. I don't know what the function is yet, so I'm going to put f of x. Eventually, we're going to actually have an equation here. Is equal to, what was the y value we found? 3. Okay? So the only things right now that you're going to be filling in are a and b. That is the only things you'll be filling in right now. Eventually, we'll get there when we're filling in other things. Okay? Right now, we're only filling in a and b. So a and b. So this is a and this is b. Are there any questions? Do you need to stand up? Need to go get water? Sure? Okay. Good? Okay. For sake of time, I'm going to skip this so that we can get to the graphs, because the graphs are the main part. Okay? We'll go over more of examples like this tomorrow in your groups and individual. Okay. So let's look at these. All of these functions right here, I'm going to give you examples of when it's defined as a limit and when it's not defined as a limit. okay? So all of these examples right here have a defined limit at 4, okay? That's what that means. All of these are going to be equal to 4. So let's look. This asks me for the limit as x approaches 2. What I like to do is, and you can do this if you want, I like to draw a line going up and down vertically at 2. Excuse me. So that this way, can you see that line? Sort of. Okay. This way I know where my graph has to get to, okay? This is your x value. This is x equals 2. In order to find a limit from a graph, you have to go from left to right and then right to left. Because remember, both sides of the graph have to touch that same point, okay? So what you want to do is you want to go from left to right and then right to left. Again, right to left and left to right of that point. So this is the left side of the graph. I'm going to start at the left side of the graph and go till I get to that point on that x-axis, or on that x value. And then I'm going to start from the right now and go to the left. If you circle the same point, or star, or highlight, that's what I do. Whatever you need to do to understand this is up to you. I like to circle so I know where I'm going, okay? Whatever you need to do. If you circle the same point, that means your limit exists at that number. That is why the limit exists at 4, is because both parts of your graph touch it at that point. Does that make sense? No? Okay, I'll explain it again. Okay, I'm going to zoom in more, okay? All right. So, in order for a limit to exist, to have its own number, the left side needs to get to the same number as the right side, okay? Okay. So, if I trace from the left side of the graph and stop here, the number's 4. Got it? Okay. I don't have another highlighter, so I'm going to use brown. If I go from the right side of the graph and stop here, that number is also 4. So remember, this is 4 because it touches that point right there. Okay? Does that make sense now? Sure? Okay. Good? Can I move on to... Yeah.
Wait, so it's just whatever number it is on first?
Yes. Yeah. Well, yes and no. If you'll see on the back side, there's going to be a graph where it lands at different points. That means it doesn't exist. But we'll get to that. Okay? But if they get to it together, that's the point. Okay? Questions? All right. Good? A little bit more understanding? Okay. So let's look at this one now. I'm going to start at the left side of the graph. And I'm going to draw the dotted line. I'm going to start at the left side of the graph and stop at that dotted line and circle the point. Good? Do we see that, what I did? Again, I started at the left side of the graph and I just drew until I got to it. Now, I'm going to start at the right side of the graph and draw until I get to that dotted line and circle my point. That is 4. Okay? That's why that limit exists. I see some of you like, but wait. This point right here, this is called a jump point. This is called a point of discontinuity, this. Even though this is off the graph, does my graph get to that same number? Do I circle the same number? Yeah, I circled the same number. That means your graph is getting closer to that number. It doesn't have to equal the number. It just has to get close to the number. Remember, the definition of the limit is approaches, gets closer to. It was not equal to. Okay? Does that make sense? I'll say it again. Even though I have this point down here, your graph, when we squeeze our fingers, I like to do fingers too. Squeeze my fingers together, it gets to this point. I don't care about this point because my graph doesn't even touch it. Got it? Good? Okay. I'll skip this one because that one is just like this one. We just have to move. Okay? I want to get to the non-exist one. So flip over. Okay, so again, all of these are going to be not exist. These are do not exist, okay? And you'll see why in a minute. All of these will be does not exist. And we write this as this. X approaches 2. This is not really math notation, but I hate writing does not exist every single time, so I'm cool with you abbreviating, okay? It's not really real mathematical notation, but you'll see if you take calculus or stats in college, they write that all the time, D&E, okay? So let's look at this. I am looking at 2 again. So here's my line. This is called an asymptote. Did you learn about asymptotes last year? No? Okay, we'll talk about it later then. I'm going to start at my left side and go and follow to my right. This does not get to any number specifically, okay? It doesn't touch a number. It's going along this line. Now, if I go to the right side, it's also just going up and up and up. It's increasing, 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 not touching any value. This is why this graph does not exist. This graph does not exist. Does not approach a value. So I'm writing rationale underneath so that this way you know what it means, why it doesn't exist. Are there any questions on that one? Okay. So now let's look at the next one. This one does not exist, and I'll show you why. So I'm going to start, am I going too fast? Anybody? Okay. I'm going to start at the left side of my graph. Here's 2. I'm going to start at the left side of my graph. I'm going to stop and circle my value. Okay? This value is -1. Okay? Then I'm going to do my right side of my graph and circle it. This value is +1. Did I circle the same number? Are these even the same number? No. So because, this goes to your question, because these are not the same number, there is a jump here. There is a jump. That is why this does not exist. Okay? That's why this does not exist. Because there's a jump and these two are not the same number, which is different from this one. Yes, there's a jump, but your graph approaches that same number. Do we see the difference in the two? No? Yes? Oh, sorry, I'm looking behind you. Yeah, I'm looking behind you. Good? Are we sure? Okay. Let's look at the last example before we get to an actual example. Okay, so here's 2. Do I have a left side of the graph? Yeah. Do I have a left side of the graph? Like, can I take my pen or pencil or finger and go from the left side? Let's look. So there's 2. No, right? This doesn't exist because I cannot determine what's going on with the left side of the graph. Okay? I cannot determine what's going on with the left side of the graph. So the left side, so to the left. Oh, let me write the rationale here. Does not approach, can't spell today, the same number. Sorry about that. And then this one is to the left of x equals 2 does not exist. There's no part, does not exist. Questions? So we've seen when it exists and we've seen when it doesn't exist. When we're done writing that, we're going to go through a full example of existing and not existing and jumps and points. And then we'll be done for today. And tomorrow we'll practice and have an exit ticket. Are there any questions on these 3 graphs or the 3 graphs before it? We sure? Okay. Oh, still writing. Let me know when you're ready. Ready? Okay. All right, so let's look at this example. I'm keeping just the graph up here because you have the bottom part, so we're going to work on A. Which x value am I looking for the first one? What x value? You can't see it up here because I want to keep the whole graph up here, so look at your paper. What x value will I be drawing that dotted line from? Do we know? -2. Because remember, this is the one we're trying to look for. Okay? So, if we go to -2, I'm going to draw that line through -2. Any questions so far? Oops, that's not what I wanted. Okay. Wait. Okay. So I'm going to approach from the left and stop and circle, or you guys can highlight. And then I'm going to approach from the right. So this is why seniors think like, oh, I need to stop here because it goes up. It does not matter. It doesn't matter. You can follow the graph until it gets to that point. So I'm going to follow the graph, follow the graph, follow the graph. Okay, and I'm only going to write my little arrow here. Okay, and then circle that number. Does it get to the same point? Have you circled the same number? Have I circled the same number? Ooh, somebody said no, somebody said yes. So let me do it again. So I go from the left and circle this point, right? I go from the right and I circle this point. Is that the same circle? Yes. Okay? So that means I'm going to estimate this to be about 0.5. So that means it's going to be a half, or if you want to write 0.5. Are there any questions? Sure? Good? Okay. Okay, so what's the next one I'm looking at? What x value am I looking at? 3. So I'm going to look at 3. So I'm going to draw my line through 3. But Miss Santana, there's no 3 there. That's okay because I have this point here. And remember, this is the x value. So I'm going to draw the dotted line through 3. And seniors, we've got to make sure that we understand each part of the graph. If you need help, come ask us. Oh, I have office hours Monday after school and Wednesday morning. So let's follow the graph. I'm just going to follow it here because I don't want to have too many lines until I get to 3. And I'm going to follow it here until I get to 3. Does it approach the same number? Good. Yes, it does. We get closer and closer to what value? 3 is the x value. Remember in a coordinate, the coordinates are x comma y, and we're looking for the y value. -1. Questions? Okay. I'm gonna get to 0 and then we're gonna stop there because we gotta put our calculators back. Can anybody tell me, before I even do this, what the limit is? So here's 0. The 0 is the axis. Any ideas? Here's 0. If I'm going from the left and the right, what is the limit? Is there a limit? What do we write then if there's no limit? D and E. And let me explain to you why. So I'm going to take, and I'm sorry I'm going a little bit fast. We'll have some time tomorrow. Here's 0, which is the x-axis. I'm going to go here on the right and circle. I'm going to go here on the left and circle. Have I circled the same number? Did I circle the same number? No, we didn't. That's why it doesn't exist. Okay? We're going to have more practice tomorrow. I'm sorry I rushed through that last one. We'll have more practice tomorrow. Can we please, orderly if possible,